The vagus nerve is often described as the body's information superhighway, and for good reason. Spanning from the brainstem to nearly every major organ, including the heart, lungs, and digestive tract, this nerve forms the core pathway of communication between the gut and the brain. What makes it exceptional is not just its reach, but its speed and directionality. Signals travel in both directions, and they do so in milliseconds. In recent years, science has revealed that the vagus nerve is much more than a passive conduit. It is a dynamic, regulatory interface shaping everything from emotional states to immune response to eating behavior. Understanding how this nerve functions offers critical insight into health, mood, and chronic disease, and may point the way to innovative treatments for conditions long considered unrelated to gut activity. At a basic anatomical level, the vagus nerve, cranial nerve X, is composed of approximately 80% afferent fibers, sending signals from the body to the brain, and 20% efferent fibers, sending signals from the brain to the body. This shows that the brain is not just telling the gut what to do, it is also listening to it, constantly. And the signals it receives don't just concern digestion. They encompass microbial activity, nutrient sensing, immune status, and even emotional tone. Through this two-way channel, the gut and brain maintain a real-time conversation, an astonishing biological dialogue that can shift mood, regulate appetite, and modulate systemic inflammation. One of the fastest and most intriguing examples of this communication occurs via specialized enteroendocrine cells called neuropods, which reside in the intestinal lining. These cells can directly synapse onto the vagus nerve and transmit electrical signals to the brain within less than 100 milliseconds, a speed rivaling that of sensory neurons in the fingertips. These signals allow the brain to instantly know what's happening in the gut, whether certain nutrients are present, whether microbial populations are shifting, or whether inflammation is brewing. The vagus nerve then coordinates responses across multiple systems, including hormonal release, changes in gut motility, and adjustments in mood or appetite. Emotionally, the vagus nerve plays a central role in affective regulation, often referred to in the context of the gut feeling. Signals from the gut can modulate activity in brain regions like the amygdala, prefrontal cortex, and insula, all of which are involved in processing emotion, threat, and self-awareness. Disruption of vagal signaling has been linked to anxiety, depression, and trauma-related disorders, while vagal stimulation therapies are now FDA-approved for treatment-resistant depression and epilepsy. These therapies work by electrically stimulating the nerve at the neck, demonstrating how powerfully the gut-brain axis can be modulated through the vagus. In terms of hunger and satiety, the vagus nerve is the brain's primary way of detecting fullness in real time. As food stretches the stomach or as hormones like CCK, GLP-1, and PYY are released from the intestine, vagal afferents send these signals to the nucleus tractus solitarius, NTS, in the brainstem. From there, information flows to hypothalamic centers that either drive or inhibit feeding behavior. This means that satiety is not merely a result of blood sugar rising, it is felt through neural input. This system helps explain why certain types of food, particularly ultra-processed ones that bypass normal digestive signaling, can lead to overeating. They short-circuit the gut-brain feedback loop. The vagus nerve also plays a foundational role in inflammation regulation through what's known as the cholinergic anti-inflammatory pathway. When immune cells detect an inflammatory challenge, the brain can downregulate that inflammation via vagal efferents that release acetylcholine, which binds to receptors on macrophages and inhibits the release of pro-inflammatory cytokines like TNF-A and IL-6. This feedback loop helps explain why chronic stress, which suppresses vagal tone, is associated with elevated inflammation and disease risk, ranging from cardiovascular disease to autoimmune conditions. But perhaps most fascinating is how vagal function appears to be trainable and plastic. Practices like deep breathing, meditation, cold exposure, and exercise can enhance vagal tone, a measure of how responsive the nerve is to feedback. Higher vagal tone is associated with better mood, improved stress resilience, lower inflammation, and more balanced metabolism. This offers a compelling case for lifestyle-based interventions that target the vagus indirectly through behavior without the need for pharmaceuticals or devices. As the central link in the gut-brain axis, the vagus nerve challenges the idea that body systems are siloed. Its millisecond speed signaling suggests that psychological and physiological states are co-created by constant bidirectional input. What we feel in our gut isn't just metaphorical, it's real-time data. What we eat, how we breathe, whether we sleep well, and how we manage stress all directly affect vagal tone, and thus our brain's perception of the world. In conclusion, the vagus nerve is not just a highway, it's a regulatory switchboard managing the balance between digestion, mood, immunity, and metabolism. Its influence is so vast and so immediate that it invites a rethinking of medicine itself, from a collection of separate specialties to a more integrated, systems-based approach. The vagus nerve doesn't just move signals, it coordinates the story of who we are 1 millisecond at a time.